Welcome to Circuits and Devices Lab. In today's video, we are going to learn how the experiment number 10, verification of superposition theorem, can be performed using virtual lab. So for that, first we have to go to Google and click virtual lab in the search bar, and then you have to select the electronics and communication branch as we have done in the previous video. Do the same procedure. Then you have to go to the analog signals networks and measurement lab to do our experiment, that is verification of superposition theorem. So click to that. So this is your page which shows the virtual lab introduction. So in that you have to click list of experiment. So once you select this, you will be shown a various list of experiments. So in that, select verification of superposition theorem to perform that experiment. So click to that. So this is your page which shows the verification of superposition theorem. So this is the theory part. So superposition theorem states that the current through or voltage across an element in a linear bilateral network equal to the algebraic sum of the current or voltage produced independently by each source. So we have to verify this statement. So for that, you can go through the procedure how the superposition theorem can be performed, and then you can select the procedure to see the step-by-step procedure to be followed to perform this superposition theorem experiment. So next you can click the simulator button to start our experiment. So once you select the simulator, you have to perform your experiment by clicking to this link. Click here to perform the experiment. So select that. So this is the page which shows the verification of superposition theorem. So this is your circuit diagram which is having the resistance R1, R2 and R3. It also has a voltage value V1 and V2. So first procedure, set all the resistance R1, R2 and R3 and choose any arbitrary values of V1 and V2. So you can vary this R1 value to any value according to your wish. So you can change the value. So R1, R2 and R3 can be changed according to our wish. So you can set any values. You can also change the V1 value and V2 value also by clicking this button. So then in experimental part we have to do the first case. So case 1 is in presence of both the sources. So in order to perform this case 1, you have to select the case 1 tab. So click the case 1 tab. So in that, select switch of S1 and S2 to power. So you have to select the switch S1 to power, and this is the switch S2. DP/DT switch, double pole double throw switch S2. Here also you have to select the power. Yes. Then next step, simulate the program and observe the result from case 1 tab. So we have to simulate the program by scrolling down. So just select the simulate button. So we have to select the switch S2 as power. Then only we can simulate the case 1. So select simulate. Now the readings A1, that is I1 reading, and A2 ammeter reading is I2, and A3 ammeter reading is I3. So these three current readings are noted here. And next, case 2, in presence of V only. So in order to perform this case 2, you have to select the case 2 button and then follow the procedure in case 2, which is apply S1 to power and S2 to short. So you have to select S1 to power and S2 to short. So next step, you have to simulate the program and read the ammeter values from case 2 tab. So scroll down, simulate, click the simulate button. It will be shown the values of I1, I2 and I3 in ammeter reading. So next step, you have to perform the case 3 in presence of V2 only. So for that, you have to select the case 3 button. Next, apply switch S1 to short and S2 to power. So select the switch S1 to short and S2 to power. Okay, you have selected, and then simulate the program and read the ammeter values. So you have to scroll down, click the simulate button, and you can see the readings of current I1, I2 and I3. So now we can note all these readings in the observation table by selecting this fill data to the table button. So click that and click OK button so that your observation table is updated. So then scroll down to see your observation table. So this is your observation table which shows the first case in presence of both V1 and V2. We have obtained I1, I2 and I3 value. So second case in presence of V1 only. Here also we have obtained the current value I1, I2 and I3. So this we can represent as I1 dash, I2 dash and I3 dash. Then in presence of V2 only, we can obtain I1 double dash, I2 double dash and I3 double dash values in the ammeter. So how we can verify the superposition theorem means, so according to our theorem, I1 is equal to I1 dash plus I1 double dash. So here I1 value is 0.39032 and your I1 dash value is this value 0.56774 and your I1 double dash value is minus 0.17742. So formula is I1 is equal to I1 dash plus I1 double dash. So if you add these two values, you will get the value which is same as 0.39032. Similarly, I2 is equal to I2 dash plus I2 double dash. You can also add these two values and verify the answer should be minus 0.10645. So next step is I3. So this is your I3 value which is equal to I1 plus I2. So if you add these two values, you can get this value I3. So I3 is equal to I1 plus I2. So if you add these two values, you will get this value. So thus we can verify the superposition theorem. You can also vary the resistance value and voltmeter value V1, V2 in the circuit diagram and obtain the next observation reading. So vary by the use of this button. You can vary these values. Here also you can vary R2, R3, and you can vary the V1 and V2 and do the same procedure to get the next set of readings and fill that readings also to your observation table here. So similarly you can do the same thing for 2 to 3 readings and you can verify your superposition theorem. Thanks for watching.